Morning, everyone. Woman Jacob, welcome to Scienceworks this morning, and welcome to the third day of our Design Beyond Earth series. It's fantastic to have all of you here today joining us. I'd also like to acknowledge, though we are running this as a hybrid event, so we've got lots of people joining us online. So if you're joining us from your homes or from your workplaces, welcome as well. My name's Jonathan Shearer. I'm the General Manager here at Scienceworks. It's my pleasure to be welcoming you. I would like to begin by acknowledging the traditional owners of the land we're gathering on today. We are on the land of the Bunurong people of the Eastern Kulin Nation. I'd like to pay my respects to elders past, present and emerging. I think it's really appropriate as we look at how we can understand more about the world we live in this case using technology to create, this better, more thriving, more sustainable future. Just to acknowledge that there's generations of knowledge of how to live in a thriving manner on this land through our First Peoples, and there's a lot we can learn through that. I'd also like to acknowledge that we will be Auslan interpreting this session, so thank you for your services as well. But welcome to Design Week. It's really great for Scienceworks to be able to partner with Melbourne Design Week. It's a fantastic opportunity for us, and it couldn't be a better weekend for it. Today is Scienceworks' 30th birthday. Oh, thank you. We're super excited. So for the past 30 years, we've been engaging people of all ages with the excitement and then the possibilities of science and technology. And we've hopefully been touching lives, and we've hopefully been inspiring people. Well, given that we've been around for 30 years, we've hopefully inspired people who are now working within this STEM field and might be designers even working within the space industry as well. So that's absolutely fantastic. So today is our third day of being a Hub for Design Week. I've seen a few people who've joined us every single day and every single session, so welcome back. But if this is your first time joining us, it's an amazing talk we've got for you this morning, and it's also the first of our future forums. So it won't be Design Week every single week, but we'll be doing a lot of these future forums as we move through the year, so keep an eye on our website. This morning's presentation is actually, we've ticked over to afternoon actually, sorry. This afternoon's presentation is a collaboration between Scienceworks and the UK Science and Innovation Network. So it was great to have their support in preparing this session, and it's great to have Lara joining us representing the network. We're really keen to make sure that not only do we share some of the amazing stories you'll hear today, but we answer all your burning questions. And since we are split over an in-person audience and an online audience, we're going to be using Slido to take your questions today. So if you'd like to be contributing questions, you can either scan the QR code up there, or you can go to slido.com on your phone and you can use the code EARTH2703. And any time during the presentation you can be submitting questions. But also if you're following the questions and you see somebody else's question that you'd like answered, you can like that question and upvote it to the top of the list to make sure that we get to it in the question time. If you're joining us online, it's even easier. So the page you're viewing us from, you can scroll down and you'll find a Slido box, and you can submit your question directly through that webpage. I'd like to introduce our host for this afternoon. So our host is Claire Kenyon. Claire is also known as the Red-Lipped Astro online. So if you're following her on her many accounts online, you'll find her through Red-Lipped Astro. And Claire is an astrophysicist and a science communicator, and she has a flair for lifting the veil on the mysteries of the night sky, space, and everything in it. She spends her days and her nights giving public talks, running telescope observation nights for schools, and discussing interesting science topics on TV, radio, through social media and podcasts. And her research takes her deep into the heart of very energetic galaxies called quasars, to the central supermassive black holes within them. So without further ado, please welcome Claire Kenyon. Thank you, Claire.
Thank you so much, Jonathan, for that kind introduction, and thank you so much for being here, everybody physically and everybody online. We are in for an amazing discussion. I've been lucky enough to have a chat offline with all of you, and I'm so excited about what we've got for you. I would also like to acknowledge the traditional custodians of the land on which we're meeting today and pay respects to our elders past and present and emerging. This land is steeped in rich traditions of many tens of thousands of years. of star lore and astronomy, from the first Australians who used the sky to guide their navigation through space, time, and life. The star Altair, which you can find at the moment in Melbourne, just in the east-northeast part of the sky, just before dawn. It's a bright blue star. That represented Bunjil the eagle to our first name, for the people of the Kulin Nations. And Bunjil looked down on these people of the Kulin Nations and guided them to live better lives. Like Bunjil, there are myriad satellites above our heads right now which watch over us and have the potential to improve the ways in which we live and our impact on the world around us. Today's Design Beyond Earth session is focused on the future of Earth observation. We have an incredible and diverse panel today to take us through their journeys into space, both in terms of design and innovation, and quite literally, space. We will hear about their innovations, successes, challenges as we step forward into the future of Earth observation. As always, we are very, very keen to hear from you, both here and online. So please pop your questions into the Slido app and we'll do our best to get to them. On our panel today, we have Dr. Shane Keating, Senior Lecturer at the School of Mathematics and Statistics in University of New South Wales and avid guitar player. Dr. Moira Smith, the Director and Chief Technology Officer of DCAT, and a fantastic story I'm hoping coming from you about coming to Australia and problems faced. And also Matthew Moat, Head of Sales at the agricultural technology firm Deep Planet, and a country boy from the Barossa Valley who occasionally might have trouble with maps. I'm sure you'll tell us about that in a minute. I'm going to direct our first question to you, Shane. We're going to start off with you. We're here today to hear about the future of Earth observation, but in our chats, you thought it should be called something different. Tell me about that.
Yeah, thanks, Claire. So Earth observation is about measuring and monitoring our planet from space. But of course, our planet is 71% covered by ocean. So we should really be calling it ocean observation with a couple of dry bits. Now, I'm an oceanographer, so obviously I'm biased. And I'm sure that Matt and Moira will be able to fill in the bits that are dry.
Do our best.
But you know, I think one of the really exciting things about Earth observation is the way that it's revolutionized the way that we explore our own planet, and in particular, the most remote parts of our planet, the most expensive and difficult to get to. So I'm thinking here about, the vast open ocean, the frozen poles, the forests, the truly last wild places on Earth.
Yeah, fantastic. I can't wait to hear more from you, Shane. Moira, we have just heard a lovely lilting Irish accent. Now it's time for a wonderful Scottish brogue. You told me earlier that you've fallen in love with Adelaide. Mm-hmm. So fill us in a little more about what you've been up to and what's brought you here. And don't worry, Shane will not take up 71% of this conversation. I just want you to know that.
But no, well, thanks, Claire, and I take your point. Definitely the oceans are the ones that are all too often forgotten, and I'd support your idea there completely. But we tend to look at the Earth. But coming back to your question, Claire, around coming to Australia, I was fortunate enough to, I used to work in defence industry, so we were using Earth observation to look down on the Earth and find difficult things, track them, classify them. And then part of that work was with South Australia. We were working with your defence agency. We were trying to protect Australia and doing missile warning systems so that if missiles were coming in, we could try and detect them quickly. And it was really through that experience of coming to Australia, starting to work with Aussies, that I got quite inspired, and I could see the energy, enthusiasm, and the sort of positive vibes that are going on over here, and particularly for space. And so that was enough to try and get here, and here I am.
Fantastic. So Moira is an expert in squeezing the value out of data, Matt, as I'm sure you're aware, and we'll definitely get to hearing more about that today. But you, Matt, you are working in a field that squeezes value out of grapes, amongst other things. It's not all just the traditional boots stomping in a barrel, is it?
Yeah, no, not at all. I think a lot of people look at the wine industry and think, the traditional, basket presses and, in the vineyards, and what we're doing at Deep Planet is being able to bring Earth observation and technology into that space to help, especially in Australia where we have vineyards at large scale and we don't have we have high operating costs in labour and electricity and fuel costs for driving tractors and so forth, to actually be able to monitor those vineyards at scale to be able to predict yield, maturity, health of the vines, and so forth. And it's really important from an environmental perspective, because vineyards are essentially what we classify as the canary in the coal mine when it comes to agriculture. It's going to be the type of plants that are most impacted by climate change first, before you start seeing it potentially in other more hardier crops.
Yeah, fantastic. So it sounds like you all have very different customers. And of course, we know that design is all about, making new technologies, but also designing for people. So Shane, can you tell me a little bit about who are the people that you are designing for, and what sort of innovations are you coming up with to sort of address their concerns?
Sure. Well, based at a university, we don't usually call them customers. We call them sort of partners or collaborators. But yeah, I collaborate with a wide range of government agencies, sort of from NASA, the French Space Agency, through to here in Australia, the Australian Antarctic Division and the Bureau of Meteorology, all really big users of Earth observation data, or generators of Earth observation data. But I'm also increasingly working with private companies. So for example, Spire Global is a UK-based satellite company based in Glasgow.
That's right.
And we're working with them on looking at sea ice from space, so using small satellites called CubeSats. I hope we get a chance to talk about them later, to sort of look at Antarctic sea ice and monitor how that's changing in a warming world.
Very important for climate change as we move forward.
Yeah.
Yeah, and so Maura, both you and Shane are part of a Space Bridge collaboration, which is the first of its kind between the UK and Australia. Yeah. Would you be able to tell us a little bit about that and what that's for, and what you're achieving with that?
Absolutely. So this is an exciting new development, really, with now Australia having its own space agency. And of course, Britain got very close ties with Australia, and so the UK Space Agency was very keen to start working and collaborating, which it's doing at a whole different range of levels. And the bit that we're involved with is this Space Bridge, idea being that they were looking for collaborations, as you say. So particularly the need of Australian businesses or universities to work with UK businesses or universities and start building those collaborations that are going to help both countries. And so we were fortunate enough as DCAT to work with Adelaide University, and that's their Plant Phenomics Institute or facility. So those guys are expert on your agriculture here, which was a perfect match with us, because we are looking at what can you take from the data from space. Can you help with yield predictions like Matt was talking about, but not for vineyards? So maybe your main crops like wheat and barley and so on. So could we work with them to look at the satellites that are coming online? So they're called hyperspectral satellites. So this will let you have almost fingerprint what's on the ground. Most things have a sort of natural fingerprint if you look at them in the electromagnetic spectrum. And so traditionally these things have been available for defense, but not so much for agriculture. And so we're looking to see, can we help yield predictions, in particular to really help sustainability of crops here in Australia, but also worldwide.
Oh, wonderful. So to get this right, just to make sure I've got this and I've understood this, you're more into the actual satellites and looking down and getting and actually obtaining the data and making the best out of that. And I know you use a lot of AI as well, and you're more into sort of squeezing stuff out of the data that's already there and sort of liaising between people that might want to use that data. Is that correct?
Absolutely. It's saying to clients, what's the problem we're trying to solve?
Right.
And then what are the ingredients that are best needed to go into that recipe to give you the answer? And how often do you need it? At what resolution do you need to look? How finely do you need to look at something? But also, what can you afford? And that's a huge thing for us. Many of our clients are not government. We do work for government, but there's generally a different price point. So if you're taking, we work for generally businesses, but even they're very, very price sensitive, thinking about their customers. And so, yeah, that our expertise is very much in taking those ingredients, different sensor data, other pieces of data, and fusing them and mathematically optimizing what the result is.
And so you've just said the big dollar sign is very, very important, and of course, being an actual industry and working with farmers and individuals. Can you tell us a little bit about how we go from this sort of thing, which is big data and big government, big department sort of stuff, into more commercialised and bespoke things for individuals?
Yeah, absolutely. I mean, at the end of the day, technology, think about it at, the easiest probably example is think about solar panels. People don't put solar panels on their roof purely for the environmental benefit. They do it because they get a return on their investment. And the technology that we're talking about is very much the same. The biggest challenges in the adoption of ag tech and this type of tech in the ag space is show me a return on investment. And sometimes it's not, especially at the right start of a project, sometimes it's not very easy to have a calculator that tells you if you use this technology you're going to save X amount of dollars per hectare. But it's still very much there. We're still, I guess, fairly young as a business, co-developing still as Shane was saying, with our partners, with our customers, co-developing, what are the challenges that they want to solve, and then you can't invest in the technology that it makes it too expensive for it then to be in a practical solution. So you need to really be clear on the challenges, what they are, and I think one of the best customers that we've had that from is Pernod Ricard winemakers, where the chief national viticulturalist said I've got two questions for you. How much is out there? So they want to know their yield, and when is it ready to be picked? One of their biggest challenges was futile transport, where they would have a block that's got a target BOME or sugar level of say 14, and they think it's right. The grower's done some manual sampling. They send trucks down, they send harvesters down, they have people waiting at the winery for 200 or 300 tonne of fruit to come in. It comes in and it's 13 BOME. Stop picking. All those resources are sitting there. They have to pay for the truck still, they have to pay for the people in the winery. And that's where they're seeing a real, in their logistics, advantage in their business. And then that extrapolates out into other features. But the main two things for them as a large corporate was, let's get our logistics right, because that's the lowest hanging fruit, shall we say, that we can actually we can shift the needle on. You have to know what you can shift the needle on, and then you start building out other things from that.
Yeah, absolutely. So I wonder how many people here know that maybe the bottle of wine that they're drinking has actually been part of this Earth observation process already, potentially. Mm-hmm. And going into the future, there will be a whole bunch of things. I bet you will know on the panel here that we've got an excellent question coming in from Slido. So please, folks online and in the audience, do get those questions in, upvote them. But one of the questions we've received here, from the wonderful name of Anonymous. I wonder who that is. They're asking, what sort of technology and what sort of devices and what sort of information do you think we maybe use every day that we don't even realise is coming from satellites in space and from Earth observations? What's helping us, or sometimes hindering us in our everyday lives that's coming from up there we're not aware of?
Sure. Well, I mean, we can think of the phone in our pocket, right, has GPS on it, right? GPS works by having satellites up there beaming down signals that have a time signature on them. If you have enough in the sky, you can figure out by triangulating the difference in the times where you are on Earth. That's amazing enough as it is. But also, those signals bounce off the surface of the Earth, and when they do, they have a fingerprint. They carry some information about what they've bounced off. It could be soil, it could be trees, it could be roads, it could be sea ice, it could be the ocean. And companies are now using that data, what we call signals of opportunity, to improve weather forecasts, to improve safety at sea, shipping through ice, and so forth. So there's lots of ways that just GPS is used. I work with the Bureau of Meteorology. They use measurements of temperature, they use measurements of ocean pressure, they use measurements of wind speeds and so forth, all made from space, and that all is filtered into our weather forecast for tomorrow. So that's one way that we use space data all the time.
Yeah, fantastic.
It can be, something as simple as in the agriculture space or in that large, pastoral areas in the in South Australia's mid-north, and you've got these large stations where, you know, the previous practice used to be, you know, you go on a quad bike or a motorbike and you drive around and make sure all the troughs for the animals to drink from are full. And it was just a constant job. Someone's literally riding a bike around. Now they've got a sensor on that trough that sends a small piece of information to a satellite and then beams it back down to the farmer's phone and says the trough has still got water in it. In fact, here's a photo of it. Companies like Myriota and in Adelaide have, you know, developed the ability to send very small packets of information. So yes, full, no, empty, go and have a look, you know, basically anywhere on the earth now. So, you know, that saves, you know, you might get around to that trough and it was full, but you don't get back to it for another 3 weeks. And in that time, it's suddenly not got any water in it and your animals have got no water. So it's improving, you know, both quality of stock as well as, you know, again, the ROI for that sensor. I'm saving hundreds of hours of someone and fuel on a bike going around the fencing and lines and so forth on my property.
Yeah. And there's countless examples. That's a great one, and particularly relevant for Australia, mentioning that not everywhere is Wi-Fi, as we all know. You go to the cities or you're in the bush and you desperately wish there was Wi-Fi around. So that's a great use of those companies coming out of Australia. In fact, 2 leading ones trying to make satellite comms affordable for everybody, so that you can always communicate, whether that's with a small ping or an image or whatever it is. So that's really exciting, and that opens up all sorts of possibilities, as you say, from, you know, farmers using the tech day to day, making decisions, to large organisations, to helping us all.
Yeah, like on that topic of reaching where satellite, where sort of Wi-Fi can't reach, satellites can get to. You know, I have a project with the Royal Australian Navy trying to use satellite measurements to map beaches and map water depths. Now, the reason they need to know that is if they're going into some humanitarian mission where perhaps they don't have good maps of the beaches, they don't know where the waves are breaking, they can't land supplies. It may even be that they're dealing with somewhere that's had a seismic event, for example in Tonga, where the bottom of the seafloor has changed, right? Which means that the beaches have changed, which means that the waves have changed. So they need to be able to use satellite data in sometimes very remote or unreachable places to be able to make better measurements for the safety of not only their staff and their personnel, but also for humanitarian missions.
So it sounds like we've got a really diverse number and variety of customers or collaborators and users and needers of this data. So what innovations in this space? We talked a lot about what's needed and the customers and who's using it, but what sort of things have happened in the last 5 to 10 years or in your projects that have enabled this to come about, that we're getting better at? Shane, would you want to start?
Yeah. So I think one of the really interesting things that's happened in the last few decades is the development of these smaller satellites. So traditionally, satellites are the purview of big space agencies, the USA, Europe, Russia, or space billionaires, right? For smaller countries, developing countries, for individual companies, that's not really in their budget. But now smaller satellites, in particular CubeSats, so these are satellites that you could actually fit in the palm of your hand. They weigh about 1 kilogram. And they can be, you can put tons of them onto a rocket. So you launch a whole bunch of them all in one go. You can log on to SpaceX now or Rocket Lab in New Zealand and book your CubeSat launch, right? So, and the idea there is that you're splitting the cost of launch across many other missions, which is really bringing down the cost of getting into space. Within reach now of those developing countries, within reach of private companies, even within reach of universities and schools, right? So imagine that as an extracurricular activity, launching your own satellite.
Phenomenal. As an educator myself and a lot of things I do, that is definitely, along with, I think, robotic telescopes, which we can sort of do offline and we can, you know, while the kids are sleeping or when there's a bad weather night, we can do that. But this is just opening space up in a whole new way. I love the fact that we can sort of bring down the costs in that way to actually start doing science, and even citizen science, and small corporations, small groups are starting to participate in this space race, and it's not going to be the biggest, strongest, most powerful ones that actually win this race, which is really exciting to me.
Yeah, it's not super cheap. I mean, it'll still cost you, you know, a few $100,000 if you've got that lying around. But compare that, you know, with the cost of of going into space on, say, SpaceX, right? So I think at the end of this week or next week, SpaceX is going to launch some astronauts to the International Space Station, on an 8-day stay. It'll cost them $55 million. Right? So if you have that money, that's great. If you don't, maybe smaller satellites are the way to go.
Definitely. Wouldn't fit, though, would we? Moira?
Maybe the small people would. But yeah.
You get a discount, Moira.
But no, picking up your point, Shane, utterly. So to me, there's so kind of three things that have revolutionized what's happened in the last few years, and definitely it's the availability of that data. It's the ability to then do something with it more cheaply, and then it's to get it out to folks. So those three pieces of the puzzle have really changed things. So as you say, suddenly, it feels like quite suddenly in the last few years, the amount of data that is available, all these satellites that are up there are providing information looking down at Earth. And some of those are free, almost free to download and go and have a look at and process. Others are free to universities to work with, so you're helping that next generation of folks process. And then you add into it the fact that in the old days, that data, there was huge amounts of data to process, and it maybe took an inordinate amount of time, and you need big banks of servers. And nowadays, the cloud computing is available, and the cost of that has become cheaper as well, so that you can process maybe the whole of Australia overnight. Oh. We're talking billions and billions of pixels to cover millions of hectares, and you can do that at reasonable time and processing costs. So that's made it possible. And the final thing is you guys all have phones, you all have the internet, so you can access that information really easily. And so I think those three pieces, end to end, have made the big difference.
Yeah, absolutely.
Yeah, I mean, I double down on that with Moira, is that ability to process the information and the growth in artificial intelligence and machine learning that's allowed that to be a possibility, where you can process and turn that data into useful information. That's the most important thing. We all get lots of data, whether it's on our social media or wherever else we get bits of data, but how useful is it if we don't actually do anything with it? You have data for data's sake. I think and being able to normalise that to a farmer. The average age of a grape grower in Australia, I think, is 65 years old, and this is how we've always done it, and then changing those perceptions to be able to actually see that they can save time, save money, improve quality, is really amazing when they see those results and go, wow. And it's simple things, you'd get NDVI, which is vegetation index, which shows how vigorous your vines are. We always used to just give a map. Here's your vineyard and what it looks like today, which is what I call reactive data. I see it, I react to it. Then you start getting into, well, we'll give you a prediction of what it's going to be next week, based on also taking in the weather, the agronomy model of the crop, the historical data and so forth, and actually say to the farmer or the grower, this is what it's going to look like next week based on everything, irrigation, scheduling, whatever. So that's predictive data, and then you move, and the next step, I think, in the next 5 to 10 years is to really move into prescriptive data, where we, literally a vineyard owner would say, I've got 20 hectares here of Shiraz, I want to grow it at 10 tonnes per hectare, I want it to meet this quality grade, help me through it. Some people get a bit, does that mean I'm not going to have a job? Again, I'll use an analogy. Xero and MYOB didn't kill the accountant and the bookkeeper. They just meant that the work that they did or do is far more valuable. So instead of giving your accountant, dollars to put all your data into a spreadsheet and give you a return or a bill, hopefully not, they're actually getting you've already done all that data, or the Xero or MYOB software has already done that, and now they're giving you more valuable advice on your cash flow, on whether you should hire people, on whether you should make an investment, and so forth. And I think that's where the data will come from, and making it far more, as I said, prescriptive and predictive than where it's currently predominantly in the reactive space.
Yeah, it's interesting. Matt mentioned artificial intelligence as being one of the really interesting innovations as well in this Earth observation space. What's happening now as well is that that artificial intelligence is actually moving on to the satellites themselves.
Yeah.
Now, don't worry, that doesn't mean Skynet is coming. All it means is that the satellites are kind of making a bit of a decision about what they beam back to Earth. So one of the biggest bottlenecks for Earth observation is just the sheer deluge of data, right? The sheer volumes of data. It costs a lot to bring that down. And so what's happening now is that the satellites have little chips inside, and they're looking at what's coming in from their sensors, and they're deciding that's interesting to my user, or that's not interesting to my user, and only downlinking, if you like, phoning home with the data that they think will be useful. And I think that's been another really interesting innovation.
Yeah, and that's quite early stage, but it's going to only get better, because at the moment the power and the capacity of the processing that you can do on the satellite is a fraction of what you can do on the ground. So there's that trade-off of the amount of intelligence that the satellite can have at the moment is a lot less than at the ground, but that's only going to improve and change things and make it easier. And again, it'll become cheaper because they're sending less data down. So
it sounds a lot like there's some technical hardware advances that are, innovation and design in that space, but there's also a very large amount of innovation in the space of computing and deep learning, machine learning, artificial intelligence. When I think about what you were just talking about before, if I was to try to train a computer to look out into a crowd of, let's say, 100,000 people and pick out a person with excellent fashion sense,
you don't have to look far.
Well, so I would probably need to train that computer as to what I thought good fashion sense was in the actual interpretation I was looking for. Now, this might be a bit of an obtuse question, but how do you actually ask a computer to look for specific things? How good is it, and what are the pitfalls of that?
I just want to say your example, Claire, it's actually been done. So at Melbourne Fashion Week a few years ago, so IBM Watson, which is the big supercomputer that can beat anyone at chess and these things and whatever else, but the Watson computer, and I don't know who the designer was, and I've heard this story a few years ago, and I can't remember what year it was, but essentially what they did is they fed in a whole heap of images of good fashion. Instead of the designer taking 6 months to develop their range of clothes, they actually basically took a few weeks, and it said this is the sort of stuff that people resonate with. By looking at social media sentiment analysis and saying, this is what people in last Fashion Week, this is what people were liking and retweeting and sharing and that. And so it basically gave the designer, this is what you should make. They went and did it, and then they tested it again against the sentiment analysis on social media for Melbourne Fashion Week that day over that week, and it actually got a higher rate than all the other designers. So for me in the wine industry, where I think that's interesting is in label design. How do we choose a bottle of wine when we walk into a retail store and are faced by this wall of wine? Some of us like a more traditional label, some of us like a more funky label, some of us like with a screw cap, without a screw cap.
Just look for the number of medals.
Yeah, some look for the accolades, and some look for the accolades and the medals or the score. Some of us look more at price point. But essentially, your example has been done. In terms, I'm head of sales. I'm not technical. I'll hand over to these two doctors to be able to tell us how it works. I just trust that it works because I've seen it.
Yeah. So machine learning and artificial intelligence is kind of a buzzword right now at the moment, and you have to be a little bit careful, right? Because maybe one of the most common forms of machine learning is what we call supervised machine learning. So all that means basically is that you want an algorithm to be able to distinguish cats from dogs or well-dressed people from badly dressed people. And so you give your algorithm a whole bunch of pictures and you say cat, dog, well-dressed person, badly dressed person, and you do that again and again and again, and eventually the algorithm figures out how to predict, given any old picture, whether they're looking at a cat, a dog, a well-dressed person, or a badly dressed person. But of course, there's a lot of biases in that when you put the labeling on, right? And actually, this is a bit of an issue with artificial intelligence, and particularly face recognition really fails when you're looking at non-white people, for example, or people wearing hats, or people wearing traditional headgear. And so there are inbuilt biases, and you have to be very careful about that, even in the sciences where we consider ourselves quite objective. Moira and I were chatting earlier on. In many ways, machine learning is only as good as the sort of input that you're giving it. You feed it rubbish, you're going to get rubbish out. And it's really important, and it really hinges on the quality of your ground truthing.
Yeah.
Right?
And that's what we call this, what the truth is. It doesn't necessarily mean you're looking at the ground. It could just be looking at other people, but it's known as ground truth. And as you say, Shane, it's essential, because if you're building your model, it's trying to mimic how humans learn. So hence, some of these techniques that are used are called neural networks. So it's the neurons in your brain and how they're connected and how people learn things as children. And we're looking and we're learning. And it's because we learn that cars have 4 wheels typically. We have to learn that it's still a car if it's got different colors. And so we're learning all the time. And so that's what these techniques typically, as we talked about, the supervised method is showing the machine and it's learning. Mm-hmm. And as you say, there are some pitfalls. But if it's well designed and the folks who are designing these systems are taking this into account, and also the testing of it. So you make sure you do show it entirely different things and check that you don't get these false positives so that people trust the models. And I think that's something we haven't touched on yet is the trust element. And it's building that trust in the user community. I'm sure you've probably found this initially, you touched on it a little bit, around changing vineyard growers. How do you take somebody who's trusted themselves for years and say, here's a picture, it's come from a satellite, believe us, your yield's going to be this. Mm-hmm. And it's through that testing and proving to people that this model does work, but it also has limitations. And that's really important as well. I spend a lot of time doing validation of models. So that's proving how valid is it, when can you use it. And all models are just representations of something. And they only have certain limitations. So I don't know if you want to pick up on that.
Absolutely. I think one of the things we do to prove to our customers or partners that, say, yield estimation works is, give us your last 5 years worth of yield data, and then we'll tell you what the machine would have predicted, and so we can actually show people that the results work, because otherwise they're going, well, is it really going to work? My grapes are different. I prune differently. I mulch differently. I do different things in the vineyard. And it's, when you're talking about bias, I think of it also, it can work really the other way, that it takes out the human bias as well, that we, last vintage, so about this time last year, we were predicting out maturity curves or sugar curves as the grape ripens, the sugar level in the grape goes up, in simple terms, and we were starting to see these curves sort of flattening out. And we're not sure if that's right. And I just said to our team, I said, well, we just have to show it to the customer because we're transparent, and if we're not right, we can fix it and whatever. And they said, yeah, that's what we're seeing. We're seeing the grapes maturing slowly because we've had a bit of cooler weather. And when did you start seeing that? About 2 weeks ago. Oh, we're only just starting to see it now on our ground truthing, on our sampling in the blocks. So we're able to pick something up before they could actually physically pick it up in their own sampling regimes. So, and it's just telling us what it thinks. And the machine sometimes is, going to be wrong. As long as it's right more than it's wrong, not 80, 90%. We have scientists and lots of people in the UK that are very highly technical, very smart people. They don't want to release anything until it's 95% accurate. For me, I come from the commercial side of it. I said at the moment, predicting yields, for example, in the wine industry, in the traditional way, in the hand way of doing it, is 70% accurate. So anything above 70% is better. It doesn't need to be 95% accurate. Most growers are happy with 90%. So we often have that fight internally, should we release this feature yet because it's only 90% accurate or 85% accurate. And the scientists want it to be 95, 100% accurate before you release it. You're probably never going to get to absolute 100%. I mean, you might, but...
Absolutely. So we're hearing a couple of the challenges coming through, but before we go on to that, I just want to, you've all talked a lot about collaboration in one way or another. So, if it's between different agencies and departments, or it's between scientists or the customer, or looking at how you're actually making these, deep diving into data, you've actually got to make the connections in order to get that data and to know what you're doing. So can you tell me just a little bit, maybe a short comment on how important collaboration is? Is it international? What's the sort of collaborations that really make your innovations and designs work in this space?
Sure, I guess I'll start. Collaboration has kind of always been at the heart of science, of course, and international collaboration very much so. It's interesting, in Australia, we haven't had much in space for a long time. That's changing, so that's good news. But Australia's still been quite an important player internationally in terms of Earth observation, mostly in terms of on-the-ground kind of infrastructure, telemetry, right? So famously the dish, right? Or that ground truthing, actually calibrating instruments that are going over. So a project that I'm involved in that's led by NASA and the French Space Agency is a new satellite that'll be launching later this year. It's one of the big ones, so like $1.5 billion. But it's going to be measuring ocean currents at really high resolution, like 10 times what we're able to do now. So just to put that in perspective, that's like going from black and white television to high definition TV overnight. So it's going to completely transform how we look at the ocean and how we look at ocean currents. But of course, that's inherently a very international kind of endeavor, because you want to be able to ground truth those currents. So there's a number of Australian and New Zealand researchers who are contributing to that huge, big US and European mission by being able to go out, make measurements of ocean currents, make measurements of ocean variables like pressure and temperature while the satellite is going overhead.
So one of the innovations is definitely collaborating with Australia, I suppose, and having that international collaboration, certainly. Yeah. Did you have anything?
Yeah. Oh, definitely.
Let's go for it.
That's been our experience as well. I guess for us, we're generally working with clients, so it's businesses that are wanting to take this information and it's helping them become more efficient or offer new capabilities to their clients to solve problems. So without that understanding, the starting point for us is utterly around what does the client need. There's lots of potential with the science of what we can deliver, but we're not driven by here's a solution, can we flog it to you? It's okay, what are the problems? And that's utterly about collaboration. And the challenges are having folks who are willing to really go on the journey with you. That's not usually a quick thing, a quick plug-and-play solution. It's having, like with your Pernod Ricard, it's working with you over time. It's making sure that you're having a sort of agile approach, which means you're testing as you're going along, you're trying things out, you're understanding how they're going to consume the data. Are they looking at it online, or how do they want to interpret the data as well? And so without that collaboration, you don't get the best results.
I think one of the things as well when you're talking collaboration is collaborating with other complementary businesses that are in your space as well. You all can open up your phone and see how many apps you have. And if you're a farmer and you're looking at ag tech and I have to have another 20 different apps to run my farm, from my irrigation to my yield to my tractor app, my whatever it is, a lot of the tech that's getting developed is, and this is from a design perspective, I guess, is they're all a lot of single point solutions. What we're doing at Deep Planet is trying to be able to work with any of those companies, an API, or feed in their data into our platform and deliver that information out. Initially, when Deep Planet started, the idea was that we'd be a more of a data analytics type business, like a DCAT and so forth, and we would just give that feedback into someone else's platform that was a dominant, great viticulture platform. Well, there wasn't one, so we had to go build it ourselves. So now we go to, it might be a Centec sensor, a moisture irrigation sensor company. We've got a vineyard, they're wanting to use earth observation, remote sensing to look at their grapes. They've got a soil moisture monitor, they've got an irrigation scheduling system. They have maybe starting to already think about an autonomous tractor. And we can bring all those things together so that the farmer has one operating system, be it Deep Planet, but it's bringing in all that information. And we're, I guess, technology agnostic. We don't care what sensors they're using. They might be using a company like Bitwise that has little GoPro cameras that you put on your tractors and it counts all the berries as you drive while you're doing mowing or spraying. It's getting all that information. And that can add into additional information into our yield prediction. And the more information, as long as it's, as you said, correct information going in, we get more enhanced information coming out. So for us, it's really also about not just collaborating with the customer, but collaborating with the other technology that they're using, so that we can really provide even higher quality data back to them, and they don't necessarily, as I said, have to have 5, 6, 7, 10 different apps to control their property.
I think that's a really important point that we've hit time and time again as well, but there are commercial issues still to go around those. So technically, yes, you can collaborate, but sometimes some businesses in some spaces are not ready to collaborate. Sometimes the dominant players, there's no incentive to collaborate with a small business, for example. So there are some realities around Earth observation companies. It's easy to get the data now. It's easier to process it, but you will hit some challenges and some barriers around the collaboration of sharing the data. And it's clear that the customer needs that, but you can't always unlock it commercially. So
and I think there'll be more, more consolidation of those types of
there
businesses.
needs to be.
I always say we're in an arms race at the moment from a technology perspective. We have a number of competitors in the marketplace as well, and but it's, I think, where we're really trying to win it is through our people, and creating those really deep, meaningful relationships with our customers across multiple areas and levels of their business, by being really open and transparent and willing to API between different suppliers is really important, where, as Maura said, some of them are very closed and say, oh, we don't want your data feeding into our machine or whatever. So we're really trying to do that, because at the end of the day, you've got the practical problem of, I need to monitor my vineyard. Well, there are lots of ways of doing that. Why would you choose to do it through one company or the other? We say because of that relationship, and that we're going to meet more of the social and even the emotional side of the customer's decision making. Explain to them that you can have a sleep in on a Saturday morning because you don't have to be out in your vineyard looking at stuff because it's on your computer.
I think we're sold, aren't we? That's your Matt the salesman.
So in terms of collaboration and international collaboration, I guess, which was the question, and I think it's really interesting, actually, not so much the international part, but how Australian companies have really been growing in the last very short time, including with help from the Australian Space Agency, but to address very Australian questions, right, specific to our land and waters. Wine is a perfect example. Agriculture is another great example. But I think about things like bushfires, for example. Bushfire prediction and detection. Australian bushfire landscape is very special, right? It's a very unique environment that we need unique, bespoke solutions to.
Yeah, absolutely. And we've been involved in that recently and developing and delivering solutions. But interesting, maybe to areas that you might be surprised, like water authorities, who have burn regimes that they're managing the make sure that you get clean drinking water, and their concerns are very often around making sure that there isn't a bushfire, and then there's runoff and contamination into the water supply. And so it's not just the fire service and it's not just your local councillor that needs that information. There's a whole range of folks out there that really need that accurate understanding of how dry things are, what's the fire risk, you were talking about predictions and prescriptions, again, what's best to do, and you work with them. They've got the expertise, you take the data, but you work together to try and come up with better vegetation management, again in a sustainable way that's good for Australia, but it's minimising the risk. And again, it's a great use of Earth observation.
Yeah, fantastic.
And we're sort of seeing it the other way, Sean, where going the other way. So we're an Oxford-based, out of the UK company, but a lot of our early initial customers are in Australia for vineyards, and now we're taking the technology to France. Completely different industry. So we're having to put, bricks instead of Baumé in, because that's how they measure their sugar in France versus Baumé, and they call them, plots versus the blocks, and so even just from a design perspective, the language you're using within your platform that has to work in different areas of the world is really quite interesting, and our UI UX team is having lots of fun with that.
So it sounds like your information that's going in needs to start to change as well, and it's really great that you've brought up some challenges in what you were talking about there, because it is a question from Ian on Slido. So if you're online or if you're in the audience and you do want to get some questions in, we've got a few more minutes, we can probably fit some. Let's have a chat about the challenges, and specifically Ian would like to know, you've talked about problems and potential solutions, but what about design? Is there a design process or a philosophy that you follow? Have you used it, or are you looking to use it in the future? Tell us about the actual design process.
I know, Matt, you've been very much involved in that.
We've been very concentrated for the last 4 years or so on getting the technology right, and we're moving through that design phase now. And especially, I've just onboarded some salespeople, some business development executives, and they're looking at the platform going, it should do this instead of it doing it that way. And it's something that we're now really moving into. And again, coming back to the average age of a grape grower, and it needs to be really easy to use. We have an ag tech leader in Adelaide called Ollie Madgett that Moira knows very well as well, and he used to create games for Facebook and whatever, and he said, it has to be able to be used by a 7-year-old without telling them how to use it. And any piece of technology really needs to meet that scale. It's a challenge that we are facing right now in terms of our front end platform delivery, to be able to make it far more intuitive. It's still it is intuitive, but it could be better. It could look prettier. It could look a bit more inviting, whether you have hard corners or round corners, all those sorts of things. It's that simple, but I think it is zero. Is it doing beautiful business or something is their tagline, and it's like, we make it beautiful and it's just so seamless, and it brings in your bank feed. It's all, they're the sort of things that we need to be considering as an industry, and having it really simple so I can click on one button and it does that. And I've seen it on hardware in the vineyard as well, companies that just go, we don't have tiny little buttons, because the farmers go, I've got big fat fingers, I just need to press that button on my tractor and it does this. So from a design perspective, it's definitely something that we need to do, because we can get too, I guess, tied up in the technical and the scientific part of it, and that's probably on the journey on the road where we're at the moment.
Gosh. Well, yeah, for us, I learned that lesson a long time ago, unfortunately. It was a hard lesson to learn. But again, back in the defence days and design, we spent many, many years doing what we thought was very clever technology. If it was for helicopter pilots, it was Army helicopter guys, and they would fly really low and fast, incredibly dangerous, and they would very often, unfortunately, hit pylon wires, so electricity wires. And we lose pilots every year doing this, and I'm sure Australia does too. So the challenge was, could you do night flying more safely and alert on anything like that? That was a challenge. So we took in the radar data, and we took in the imaging data, the night vision, and we presented a real-time image for the pilot. And we had the sky was blue, the grass was green, and we did this. And we got after about 2 years, the process, it used to be called the waterfall process. So you'd start off with requirements, and then you would do design, and then you would implement, and then you would test. But that was far too late, because you're bringing in the user at the end of the process. And you'd maybe miss, when you capture the requirement, do you want a blue sky, or do you want green grass? And of course, we thought they did. But my goodness, they didn't. So we get all sorts of great language from the pilots back to us going that we really don't want this is horrible. And it was because they had been trained on technology that used phosphor, and all their screens were green. Everything was green. And that's what they were used to, and it looked so different. And the implication for them of having to be retrained and the cost of retraining all the pilots, it didn't go forward. And so that was the big lesson for me, of start with the end user, design together. It's called design thinking now, and working, and it's common sense. It's start and work together as you go. And unfortunately, people will judge you on your human interface. So if the end piece of your technology is interfacing with a human, it's entirely judged sadly. No matter how good it could be, our algorithms could be 99% accurate. But if it doesn't look good, if it's not easy to interpret, as you say, if it's the wrong button size or something, it won't sell. People won't use it. They'd rather have the 70% accuracy, but it's easy. That's why things like Apple have sold so well. So it's a great question and essential. And so many young startups, technology businesses are so excited about their tech, it's easy to forget that.
Is that?
Yeah.
Yes, absolutely. So to finish us off and round up the discussion, where are we going? What's the next 5 or 10 years going to look like in this space? I know we've used that pun so many times, and I think you can expect it a little bit more in the next discussion.
Yeah, I mean, I guess the thing I'm personally most excited about is the local Australian talent, the young Australians getting into startups in space, innovative ideas, starting new things, and kind of, again, addressing those very Australian questions and very Australian end users. I think there's a really exciting future there. And also, I think universities, research institutions engaging a bit more with that and being much more active in terms of, as a scientist, typically you kind of go, oh, we did a bunch of clever things, whiz bang, and blah, here's some data. Do something with that. And we kind of just expect that that is impact, right? But of course, impact is the way it changes of how a farmer, farms their block or whatever. That's not a measure of impact, how much data you can put out on a website. And we're becoming much more aware of that. And I think engaging with companies, engaging with startups, engaging with government agencies is going to be the future of how we change the Australian relationship with space.
Fantastic.
Yeah, yeah, absolutely agreed that we're seeing more and more collaborations, as you say, even between businesses. That's really the way forward, and with universities. And we're trying to work more with universities to commercialize their algorithms, because you can only give the customer the best solution by bringing together the best of breed. So that's a great thing. The ability for folks in Australia now to see that they've got futures in this industry. And traditionally, maybe folks thought, oh, it's really not for me, or I've maybe got to go abroad. So that to me is going to change things. And then the final piece is Australia putting up more and more of its own satellite capabilities as well. In a way, it's almost a shame to see some of the states themselves doing this when the whole of Australia needs to be doing this. But it's only going to get easier and better, I think, as time goes on.
Yeah, I think I heard a stat a while ago that there's something like 5,000 people a week or a month turning 65, and a lot of them have got businesses that they want to sell. And the opportunity for the young generation to come in and actually use technology to take something that's not very efficient and make it a lot more efficient is really interesting. And I look at that from our perspective in agriculture. So a lot of people think, and even people that have grown up on a farm, I don't want to do that job. I don't want to do mum and dad's job. That job is really hard work. They don't make enough money. And so I'm just going to go to uni and study accounting, or I'm going to go to uni and be a lawyer or whatever. I think, encouraging the younger generations to actually be able to see that, there is a cool industry out there that can really help that farming business, whether it's the driverless tractor or the remote sensing, the Earth observation satellite technology, or the drone, or whatever it might be, and being able to see that they can actually add efficiency into that business. And also I look at it, and we recently had Minister Birmingham through our office, and I sort of said to him and made the point as well that there's a lot of jobs in this industry that also aren't necessarily about being a computer scientist or a data analyst or a programmer or an AI specialist. I'm a salesman. I have 2 sales staff. I have a global events manager in my office. We're getting a marketing, chief marketing officer soon, So recognising, I guess, especially also for government, that these high-tech industries are creating a lot of other jobs than just the high-tech jobs. And that if people go, oh, well, not everyone's going to be a computer programmer. That's right. But just like people that used to design and make cars in this country, they had a lot of other industry jobs within that industry. And I think it's really important that governments also recognise that side of it, and that we get into the schools and we talk to students, because hey, the job I have now didn't exist 20 years ago.
Yeah, and I think the thing about innovation in the future is you don't know what it's going to bring, right? I mean, we have no idea what's going to be the next big thing in 10 years' time. It might be something unimaginable, and in many ways that's what sort of basic research has to be about. Basic space research needs to be basic. It can't be just applied or commercial research, because we don't know what that big thing
that long-term
is.
investment.
I was reading an amazing article about NASA had commissioned a study to figure out how much stimulation came from basic research, and they found that every dollar they spend on basic space research, this is NASA, right? So sending things to the moon or sending things to Mars generates $3, so $1 to $3 of benefit to the economy in the first year, right? That's phenomenal. That's amazing. I mean, can you imagine a return on investment like that? Unfortunately, I don't think we've really done that so much in Australia.
And I think when we're talking about the younger generation, I was told this once, and I really like it. Instead of asking your children or your grandchildren, what do you want to be when you grow up, ask them what problems they want to solve. What problems do you want to solve? Because if you ask them what they want to be, they can only be what they already know: a fireman, a doctor, you know, a lawyer, whatever, etc. Whereas if you ask them what problems would you like to solve, that gets them to open their eyes and have a look at all the things around in their world that don't work for them or do work, you know, for them, but it could be better. And that's where the new jobs are created. My partner is also a social media consultant. Again, a job that didn't exist when she was in high school. You know, so I think you need to, we need to just take our blinkers off when it comes to this sort of technology, because innovation and that doesn't happen unless we've got an open mind to what is possible.
Absolutely. Wow. Fascinating. This is so amazing. The hour has just flown past. So an Irishman, a Scot and an Australian go into Scienceworks, although the Australian went to the museum first. And no joke, we have a ripping discussion. As a science communicator and astrophysicist, I very often am asked, but why are we doing X, Y, Z, whatever? Why do we humans want to push the boundaries, figuratively and literally, of Earth's safe, cuddly, protective atmosphere, especially while there are still so many challenges we're facing at home? More often than not, my answer is along the lines of, well, picture the universe as a huge, complex game. We don't really know the rules of this game. No one's clocked it yet. No one's won. We don't know all the rules or the moves yet. But as we design and innovate, test and push those boundaries, we find ways to play this game better, and in some circumstances, what not to do. New moves give us insight into possible moves in the future and potentially into relationships between rules in the game. Now, as we've heard today from Shane, Moira and Matt, Australia has an enormous part to play in the space above our heads, and particularly in looking back down at Earth. Satellites are getting smaller, cheaper, and more accessible to small groups, companies and individuals, and every day we learn to play the game a little better. We are digging deeper and deeper into data than ever before, applying novel mathematical tools, algorithms, artificial intelligence and machine learning, and getting more and more from the data that we actually are capturing. Innovations in space science, technology, engineering and data analysis are translating into better outcomes for individuals and for humanity in many ways, including agriculture and climate change. In the words of Zoe Kirkby, the public programs producer at Museums Victoria, design has two essential parts. There's the technological advancement, and then there's that human element. Who is this for? Who's going to use this? And what is needed? Our conversation today has taken us through a wonderful design and innovation journey into the future of Earth observation. I'd personally like to thank the organisers at Melbourne Design Week 2022, the Victorian and United Kingdom governments, the US Consulate General Melbourne, the NGV, Museums Victoria, Scienceworks and the UK Australian Space Bridge program. I'd also like to thank you, our wonderful audience, no matter where you are, and thank you so much for your participation today. Some amazing questions, and I'm sorry we didn't get to all of them. And finally, a huge thanks to Shane, Moira and Matt for joining us today. It's been a truly enlightening discussion. Thank you.